Namaskar, I'm Rahul Verma, and I'm so glad that you're a part of the overall event, especially my talk, of course. So, Sandeep is going to help me with this because on the tech parts, I do okay. That okay, I have to conceptualize the talk, what are the things to be bundled together. But the things which I'm not good at all, and I've got this feedback so many times, is that given the time frame, these points were missed out, or these points should have been included, etc. So I thought that okay, I'll take Sandeep's help as my guide today, and let him drive what this presentation is going to be. So Sandeep, over to you.
Thank you so much, Rahul. I'm new to LLMs, large language models, noticing threads, posts, and comments on different professional social medias with respect to the incapabilities of LLMs like ChatGPTs. And two of them are like ChatGPT sucks at math. So it's like 0.75 into 2, it is giving 3, it should be 1.5. One example. Yeah, another example is strawberry, which says it cannot count the letter
Yeah,
R in the strawberry.
yeah.
And I was thinking that if it cannot do these trivial things, the LLMs cannot do these simple math problems, counting problems, how it would solve the complex problems of the test design. And related to that, how prompt engineering is going to help me in solving the same test design problem.
There's no short answer to your question. There is a long answer and a longer answer, and maybe longer answers to your question, because this can be, we can talk for days around it. So given the time constraints, I'll get to the point. Uh, because we know we are working under the periphery together, under the design of this topic. So of course, I have some demos ready. So I'll show the possibilities through them. I'll discuss the core problem. And while we keep that in mind that these 2 plus 2 equal to 4, or, R's in strawberry, these are shallow problems. They are a construct to prove the areas where LLMs are not good at. Of course, LLMs are not good at so many things, right? So as you correctly mentioned, there is this extreme that there are fundamental things which we expect, a child to know, and LLMs are not able to solve. And on the other hand, organizations are banking that they would, be world changers. So there is this big divide and contrast between these two stances. So what I have decided to do in the talk is that, first of all, let's not pick a shallow problem. So I'm not going to give me test cases for login and try to optimize that. Yeah.
Okay.
Or give me boundary values, the topic which was discussed in James' very well written paper, and Michael Bolton, right? So I like that overall PDF construct. It's a good study, but it has its own biases, as we would see, right? We need deep experimenting when we have to deal with LLMs. And then on the path, it's not that the problems which we come across in shallow experiments, we realize that in deeper experiments, there are even more problems in LLMs. But along the way, we also end up discovering some. So I have already run the prompts and I'm showing the results. Okay. My focus would be to show you the possibilities, to sort of discuss this contrast that while LLMs are not good at solving basic math problem, how the hell they can help us in solving complex test design problems, because of course they have a lot of math behind that. The first part, the problem which I'm picking up here is pairwise testing. So as a tester, I don't know how many in the audience have worked with this technique. So first of all, this is an example of a little deeper problem in testing. But pairwise testing, it is well documented. It's systematic in nature. It's a math problem and not a 2 plus 2 equal to 4 problem. It's a bit more involved problem than 2 plus 2 equal to 4 or counting R's in strawberry. Yeah. So I've deliberately sort of picked up a case which works against LLMs. Because otherwise, what's the fun in it, right? Otherwise, it would be a biased presentation. And then there's another case against it. Usually, people compare that manually when you do it, as a human when you do it, versus when an LLM does it. So they do this contrast. But pairwise testing is an area where a lot of tooling is already available. So you're sort of not comparing a human with LLM as a tool, you're comparing a tool with a tool also. So the basics first. Pairwise.org is your source of reference. This is an example of pairwise testing in work. The tool is an online tool. Microsoft PICT is a Windows tool which you could install, and free tool with which you can generate pairwise tests. Yeah. So you basically have variables, you have their allowed values. In combinational testing, we do not consider invalid values. And on the right-hand side, you see the results. So it is giving you 21 tests. If you're a programmer, you're building an automation testing framework, and in addition to whatever automation you were doing, you also want to integrate test design automation, use this data for data driving your test automated tests, for example, you still have many free options available. For example, Python all pairs Py, a free library. If you're working in Python, you could have integrated it into your test automation framework and then provided the parameters and programmatically calculated all the pairs. And carefully see, it gives you 22 test cases now. Tools are already available. Free libraries are also available. It's a well-documented technique, which is maths-based technique. So what's the role of LLMs? And are they any good at it, given the evidence completely against them? Let's start with that. So I have prepared some examples to show this. Let's go to ChatGPT interface. Stage 1 of prompting. I deliberately took the same example from the Python library and brought it here so that if somebody wants to draw a comparison between answers, they can draw that comparison to see the difference between deterministic tool output and the LLM output. Because there are very less testers who anyways know about pairwise testing, which is not a good thing, I would say. Please go back, study about it. It's a very powerful test design technique. Forget LLMs. First work on this technique. Yeah. All right. So you see, this is stage 1, which is laziness at its best. You think that a task is a prompt. Yeah. I want to apply pairwise testing. I have the inputs, and I am now relying on LLMs completely that solve this problem for me. So I come and type that directly. It's equivalent of saying, give me test cases for login form. That's it. That's the only thing you ask. Lazy prompt on your behalf. Yeah. And then look at the tests. It gives some beautiful response. Looks good, looks great. But you quickly observe with the background we saw in 5 minutes that this doesn't look like 20, isn't it? This is not 20. So definitely it's missing half of them. Definitely. Even when we don't know the technique, right? Now, whether these 10, 11 combinations which they show, are they also technically correct? Why do you want to trust that? This is not a trustworthy tech. And I agree to those points by James, by Michael. Don't trust these. We are testers. We are not sellers. We are not marketing people. We are not salespeople. We are not executives. We are testers. So start with skepticism. And it is right. The evidence is right in front of you. They are bad at math, hence proved. The problem is that most testers stop here. That, oh, they are bad or they are good. Or they think, oh, 10 test cases. I wouldn't have thought about them. LLM is great. They gave me 10 test cases. The skeptical ones, they're shit. They should have given me 21, 22 test cases and they're giving 10 or 11. LLMs are bad. I won't use them. I think this is where the divide in the community currently is, Sandeep. And I think that's where is the birth of your question, right? That you see these stances and there is some level of truth to both of them. That's what I believe in as a pluralist, right? All right. So,
Absolutely. You're right.
yeah. Yeah. So first part clear. They are bad at math. They're bad at test design. Hence proved. Along the way, if you notice, there is a strength. If we choose to, I need not format the data like this. I could have given an extract of a document also. And it could have extracted the variables and values, although the answer remains the same bad answer. But along the way, you also realize that there is some strength to the system. They are very good at natural language processing, which we are not used to when we use deterministic testing tool. If we go to that online tool, you see, there's a certain predefined format in which it expects the input. But in case of LLM, that constraint is not there. So remember this as we discuss forward, because people say, if I have a tool already existing, why the hell LLMs, right? Because LLMs have this role of natural language processing. Okay, so let's keep this point in mind. So although overall a failed experiment, I would say, but along the way, we realize something about LLMs, which is good. Yeah. All right. Now let's come to what people call as prompt engineering, which I think is prompt tweaking. There is no engineering to it really. So let's look at a very complex prompt now for the same prompt. So no more laziness. Let's do the job. Let's get to it. Chain of thought, this of thought, self-critique, reasoning, and let's employ all of that. All of that to the problem, whatever these courses are teaching us these days, right? Because after all, prompt engineering is just tweak the English language. Here's a trick. I tell you, keep the sentence somewhere. It would improve your experience. So, and I'm using Markdown, which is the suggested way to give structure to a complex prompt. So all the good practices are already there. We have clearly marked headings, which give mission, context, reasoning, steps, response format, and self-critique. There are step-by-step instructions on do it, and we can, of course, improve it. Now, all of this is with the hope that they are going to solve pairwise testing problem for us, right? Let's see if it happens. Maybe a little bit better experience. Step one, step two, the output is already starting to take shape. It is more structured than earlier, but it's the same 10, 11 tests. Some self-critique, what's good, what could be improved, and maybe you can iteratively prompt refinement, meta prompting, you can apply all of that. But the thing is, we are trying to use an LLM here in its weak zone. LLMs are not good at math. So we could stop here. We could stop right here because most of the testing community is doing that. It's a great post, right? I can take a snapshot that I did everything I could using prompt engineering. It's a great LinkedIn post, and I have proved LLMs don't work. But the question is, do you want them to? When you took a problem to LLM, is your focus to prove LLM can solve that problem or not solve that problem? Or you're trying to solve the problem and asking the question, what is the LLM's role in solving that problem? What is your role? What is LLM's role? And can I integrate other tooling where each role is played by some other entity and together they are able to solve the problem to my taste? So pairwise GPT, this is a custom GPT, free public available GPT. So you can imagine that some of the complexities of prompting I have already moved inside somewhere else so that you don't have to deal with it or I don't have to deal with it every time. I directly get to the problem of the test design. I give it the problem and you start seeing a sudden difference. It is giving you exactly 22 test cases, which if you remember were the number of test cases by the Python library, which I earlier showed to you. So what is the difference? Is it prompt engineering? The reality is no. The same library which I showed to you is now integrated with this GPT. So the role of the LLM is to interpret the input, extract the variables, the choices which are there, and then make a function call to the said library. So the deterministic part, the actual pair calculation is being done by a tool, not by the LLM. And when the output comes back, the formatting of it into a table, presenting it, the presentation layer is again LLM. Okay, so did we solve the problem using LLM? The question is, problems are not never solved that way. They always get solved practically by a combination of technologies. That's the truth. Okay, but then is it the solution? Is it the solution? Should we stop here? Did we solve the scale problem? Can I use it at scale? Can I parameterize it? What about copy pasting this content and creating an Excel document yourself? There are so many things which at this layer we would never be able to solve. What follows goes too technical for a very short talk. So I would quickly show you the possibilities. I take the same problem to an API layer. Okay. So how does that look like? I'll quickly show you the elements of that and let's see where it goes. So you resort to a bit of coding. You find an abstraction layer to express your prompt. So here is a YAML file expressing the same prompt, which we saw earlier. Yeah. And then you write a tool yourself as a wrapper, which is the same thing which was being done in custom GPT. Yeah. And you define some exchange format for information between the LLM and this tool. And then you find a way that how to talk to the API for this particular LLM. I'm talking to OpenAI GPT API. It's called Chat Completions API. So you make that call and execute these prompts. So how does the response start looking like? So this is a small reporting system through which I can show you that quickly. This is the same problem which we took to the custom GPT, with the difference that this time we are telling it that we have a tool to solve this problem. You communicate the definition in a JSON format, and then it runs through, it is converted to a call which you could make. In short, what it results in is these 22 tests. But the question is, we already solved it in custom GPT. Why all this complexity? Because now you can have an export. While these prompts were being executed, a CSV file was also written, which is your direct test case document, a step which you would have taken manually. And the thing is that this is just the tip of the iceberg, because if you carefully see, this is how it looks when you open it in Excel file, in this case on the Mac's native spreadsheet solution. But then we are somewhere still at the very, very beginning of engineering. I'll not go through this diagram. This is available publicly. To further the technical aspects of this middle layer, this is a model which I recently published. We are still right here at the very tip of it as a prompt. Now think about it, how you could multiply those prompts, build layers and layers and layers on top of it, and you can literally execute hundreds of these prompts in an automated way. And then, of course, human in the loop would come into play, and you can, revise the results and do much more. But the goal, the target for this particular talk for me was that I think the experiments currently happening in the community, they're too shallow. Too shallow before people are forming their opinion about greatness, or that LLMs are bad or shit or this. I think we need to do better as a community. Yeah. So on that note, I think a little longer answer to your question, Sandeep, but I hope that at least some of the points are it. And thanks everyone for listening.